My name is Cameron Crosby. As a host, this is Peter, Deep, and Chanelis. Our advisor is Professor Sweetie. So our proposal is for a medium-scale solar electric personal aerial vehicle prototype, which will eventually become into a full-scale model. So here's a video of a similar aircraft. This video shows the feasibility of such type of aerial vehicle. Engineers have been doing this in their backyard for a while now. Okay, so here I have two examples. On the left, you can see a Google Maps aerial view of NJIT to Princeton. And this is by car. This would usually take, and in this time, it would say 57 minutes. And on the right, we have the same two destinations, and it says 37 minutes. And on the right, this would be the advantages of an aerial vehicle. By doing this, it would reduce travel time by 35% or more. So here's a picture of a personal aerial vehicle made by a company Ehan in China. China has already been demonstrating its feasibility, but current energy technologies have been bottlenecking this from becoming mainstream, such as battery and efficiency. In this example, this vehicle has it's an octocopter, which means it has 8 rotors, and it's a coaxial design, which means it has 8 on the top and 8 on the bottom. So here's a picture of Facebook's Aquila drone. This is a large fixed-wing aircraft, and it's been dubbed the flying solar panel. Solar cells increase flight time, and this drone has actually been able to fly for 3 months at a time, and at the daytime it would fly 90,000 feet high, and at the nighttime it would travel down to 30,000 feet. Peter will discuss this design in more detail later.
For potential impact, according to a NASA study, the entry point for the market is viable for $500 billion at entry point. As you can see here, this is our prototype for phase 1. We started with the base for the DJI flame wheel as the airframe, and then we added on solar panels and battery components, and also 3D printed components as well. As you can see here, we were able to get the drone to take off and fly. Lessons we learned during the phase 1 was that the batteries needed a higher discharge rating, also that we needed more room for the solar cells.
So this is the full-scale model that we're building. We're going to build a medium-scale model according to these plans as well. We're constantly looking back at our design and improving it. So in this case, you can actually sit in it and you can see the solar cell fixed-wing design with a quadcopter coaxial design, which means that there are 2 motors on each wing. This improves the thrust. So we're implementing Facebook's Aquila idea, like Cameron was saying before, which adds more room for the solar cells, and it prevents battery life from depreciating as fast as compared to if you don't have this design. So this graph actually shows the data, this data sheet for the motors. So if you're running at 100% throttle at 60 volts and 143 amps, as you can see all the way at the bottom row, you're going to be using, which provides 35.5 kilograms, which is 80 pounds of thrust. So this never happens, but at that rate, with the batteries that we're proposing, it will fly for an hour, theoretically. So again, these are the motor coaxial designs. It has 2 motors on each wing, and 8 motors. That's going to be 80 pounds each for a total of 640 pounds of thrust, which provides enough thrust for a person as well as structure. So this is the final design, or we're still working, we're always looking back and working on it, but this is the design as of now. It's the furthest we come so far. And then this is a rear view of it. As you can see, it has solar cells everywhere that's feasible.
Here, as you can see, this is the list of the things that we started to order some of them for phase 2. However, it's not just that we will be able to reuse some of this component for phase 2 to final
The
full-scale model. I'm
Yeah,
sorry.
it's okay.
Also, this is our schedule so far. We are trying to follow up on a phase 1 schedule to eventually build a full-scale model after we secure some grants. As you saw in the previous slides, we need a little bit more fund to order some other parts. And our design, we believe it's far more better than the competitors that we have, because we are using a fixed wing design, which will reduce the stress on the wings due to the motors. Also, like if we were to, in the other competitors, they are using collapsible wings, which can wobble, and that's also going to increase the cost of drone building. With the fixed wing plan, it's going to reduce the stress, and it's going to improve the battery life and everything.
Okay.
Questions?
It's okay.
Have you done any serious analysis? I mean, you're using a 30 amp hour battery. Okay, how many amps does each motor take?
So it's a 25C discharge rated battery. So with 30 amp hours, 25 times 30, I think that's around like 600 or something amps that it could supply to the motors. And the motors at 60 volts and 143 amps, it's enough for the battery to supply to the motors.
Okay,
If
so
that-
the battery alone will give you about an hour?
Yeah, so one battery. So we calculated it based on 15 of those batteries because we're going full scale. At a medium scale, you just scale it down and it's going to be about the same in terms of like the weight of the drone and then a payload, an extra.
How much does the battery weigh?
So each battery, I believe, weighs 3.5. I would have to look back, but I think it's 3.5 kilograms.
Okay, but you've done all the analysis in terms of weight, payload, battery strain, et cetera, et cetera.
Yeah.
Because none of that was up there, but so if the battery alone can give you an hour, give or take,
Yeah.
how much more does the solar cells add to it? Because it doesn't look like you've got a lot
Right.
of cell there.
So that we haven't done any like hard calculations, but we're assuming it's going to be around 10 to 15%.
You really think so? Because you don't have a lot of area.
Yeah, it's going to be on the wings. There's going to be solar cells on the roof, on the back.
There's
There's,
still not a lot of area.
it's not a lot, but it's going to slow it down.
Talk to the solar car guys?
Actually, Chanel's is on the solar car team. Yeah, so we have some idea. I mean, we're putting solar cells everywhere that's possible. That's another advantage of the fixed wing, because now you have more room to put solar cells. So as opposed to if you just had sort of cylindrical arms, then you can't put solar cells there. But yeah, so
Okay, but you think you get another 10 or 15% out of because of the solar cells?
yeah, I know solar cells aren't like that much powerful, but I think it's better than nothing. Just having a solar cell there is better than not having it.
How
So
about the weight though? Is the weight Make sure they,
The weight, yeah, I mean,
repair that, not have it, and
yeah, you can have different materials, I guess. In the case of fixed wings, I don't know what they use, like some sort of,
Have you considered the aerodynamics?
yeah, it's gonna be aerodynamic, like it's an air, like if you look here,
The wings are in shape
uh,
of,
the airfoil design, or,
So the solar cells will have an airfoil shape?
yes, that's gonna be an airfoil, and it will reduce the drag and the pressure, not the pressure, load on the motors, because it's gonna actually be
gliding.
gliding, essentially. Wind gust? Yeah, it does become windy and it does like influence it, but I think having 640 pounds of thrust just on this alone, I think it will be, but no, I haven't really considered it. We haven't gotten that far.
in another project, right? Last year, similar concept, I don't know if you have it.
Yeah, that was us.
Oh, that's you, okay.
Yeah.
Now,
We have the prototype here for the small scale.
I have phase one.
Yeah.
We talked about the viability of just having all of this just for one person.
Yes.
Economics, you guys will do that more?
It would be similar to owning a motorcycle, I guess, without the back seat. So you can't really have a passenger, but
You really think you can build this for $3,000?
no, we're gonna build a small scale prototype, medium scale prototype, I'm sorry. Yeah, like it's gonna be the same look to it. It's gonna look like this, but it's gonna be like, the chair is gonna be this big. You know, it's not gonna be a full chair.
You're gonna use a dummy load.
It's going to be big enough for a 2-year-old.
Yeah.
Definitely gonna use a dummy load to check that.
Research compared to what already, you can show us already exists
Well, they're not using fixed wings. They're basically flying a big drone. So they're not using fixed wings, for example. They're not implementing solar cells. And I think that's pretty much the only difference. We have autonomous capabilities with our Pixhawk. It has autonomous features where you can actually, and they're doing that too, so.
I guess to the have you been taking in research and reviews on that? Are you at all in touch with what they're working on to leverage it to what you're working on?
We haven't been in touch, like being in touch with EHang themselves personally, or just in general, like, well, what was the question, sorry?
Aside from showing us a picture of that,
Yeah.
share with us what you know and what research you've done regarding what's out there.
Yeah, so I know that their batteries are right there underneath the car. I know the dimensions of their aircraft. I don't know off the top of my head, but I have looked at their features and what they're doing, and
On their website, they'll list of
Yeah.
specifications
Is
and
that all
everything.
just internet research or? have
Yeah.
you-
yeah, it's all just internet. We
You
haven't,
know if they're getting an hour?
they're getting 20 minutes. Yeah. 25 maybe. It all depends on like gust, you know, like it all depends on like how heavy the person that is flying in it. But yeah, it's just one person in their aircraft as well.
Okay,
Cool.
fair enough. That's it. Thank you very
Thank
much.
you.